Welcome. This is Coach Dorf. We're in section 2.5. We're going to do an example that's similar to the homework. In this example, we have a piecewise function. We have f of x equal to 2x squared minus cx if x is less than or equal to -1, and f of x is equal to cx cubed minus 5x squared if x is greater than -1. Now, the first thing you might think about with this problem is you notice that if x is less than or equal to -1, then f of x equals 2x squared minus cx, and that is continuous on -infinity to infinity, everywhere. It's continuous everywhere. Why is that? It's because it's a polynomial. It's a quadratic. So a polynomial or a quadratic, which is a special type of polynomials, is always continuous everywhere. Also, you can notice that if x is greater than -1, then f of x equals cx cubed minus 5x squared, and that is continuous everywhere. So you might say, well, there's no problem here. Both parts are continuous everywhere. The difficulty is what happens at -1. To show you how this could be a difficulty, let's just choose a value for c. So suppose c is equal to -4. And look at the graphs of these functions here. I'm going to make my axes here. There's y, here's x axis. All right, and I'm going to color my graphs. We're going to let the first one, we're going to call this y1, and we're going to call this the 2x squared. Now, since c is -4, I'm going to put -4 in here. So I get 2x squared minus cx. Since c is -4, that's going to be plus 4x. And that's a parabola. The parabola looks something like this. Now, in green here, we're going to do the second function. Again, c is -4, so I'm going to get -4x cubed minus 5x squared. And that's what's called a cubic, a third degree polynomial. And in this particular case, it looks something like this. All right. Again, the purple function by itself is continuous. The green function by itself is continuous. But the question is, when I make it into this piecewise function, is it continuous? So the piecewise function, we're going to say f, which is the piecewise function. I'm going to color that in this red color here. And so that means I have the purple for things that are less than -1, for x values less than -1. So there's the red. And then when it becomes green at things that are larger than -1, so it looks like this. And so the real question is f continuous x equals -1. And clearly it's not, because these are not connected at -1. So I know the value c equals -4 doesn't work. And the issue is here, as I change the value of the c's, my green and purple functions morph. And is there a point where they intersect at -1 so I do get a continuous function? All right. Now, you could play with this on a computer and try to do it that way, but we're going to just solve this algebraically. All right. So to do that, what I'm going to do is I'm going to take my piecewise function again, which was f of x equals 2x squared minus cx if x is less than or equal to -1, and equal to cx cubed minus 5x squared if x is greater than -1. And I want to find c so that f is continuous. So it's going to be continuous, and the problem is at -1. So what I want to do here is I want to substitute in the value x equals -1 to the top part of the piecewise function and to the bottom part of the piecewise function and set them equal to each other. All right, so let x equal -1, substitute that to both parts of the piecewise function, set it equal to each other, and solve for c. That's our process here. So I put in -1 here to the top piecewise function. So that's 2x squared minus cx. Put in x equals -1, I get this. And on the bottom part of the piecewise function, I get c times -1 cubed minus 5 times -1 squared. Now let's simplify this. -1, I have 2 times -1 squared. So that's 2 times 1, which is 2. Then I have a minus c times a -1, so that's going to be a plus c. And then on the right-hand side, I've got c times -1 cubed. -1 cubed is -1. So I'm going to get c times -1 or negative c. And then I have -5 times a -1 squared. -1 squared is a +1. So -5 times +1 is -5. All right, so I have this equation. Now I solve for c, so I'm going to add c to both sides, and I get this. Subtract 2 from both sides, I get 2c equals -7. And then divide by 2, and I get -7/2. All right, and that's the correct answer. Now, let's look at the graph of this. If I were to graph this, it's going to look something like this. X-axis, again, my y-axis here. And again, we're going to use now c equal to -7/2. So my purple function, right, when I put in -7/2, the purple one is going to become 2x squared plus 7/2 x. Again, it's a quadratic, but it's slightly different than the one we had before. Just slightly, though. It looks something like, oops, that didn't work. And then my green function, when I put in -2, so this is c times x cubed minus 5x squared. When I put in the -7/2, I get -7/2 x cubed minus 5x squared. And when I graph that, it's going to look like this. We're going to intersect here, and then it's going to go like that. And so finally, I'm going to let f of x equal the piecewise function. And so I did the purple function for x less than -1, so it looks like this. And then I do the green function for values of x larger than -1, and it looks like this. And you can see here how the red is continuous when c is -7/2. All right, hope that helps.